Okay. Alhamdulillah, today also Allah bless us to have another day in our life. So we thank Allah for giving us not blessing, and we have the opportunity to do another class. So this is chemistry lesson. Yesterday we did lesson 1 and 2. So this is lesson 3. Okay, lesson 3, L3. Well, we are still going to look at the atomic structure. Yesterday, if we are going to recap, yesterday we learned about what? The structure of an atom. The nucleus contains protons and neutrons, and the shells contain the electrons. We learned about the charge of the proton, the charge of the neutron, the charge of the electron. Okay, we learned that if there are 7, let's say if there's one proton which is positively charged, we must have one electron which is negatively charged so that they cancel each other. Okay, example is hydrogen, helium, lithium. We learn about that. Yes. Okay. Today we have to relate this to the word element. Okay, what is an element? You know, yesterday we touched on it.
Element, many atoms put together.
An element, it contains an atom, and depending on how many protons you have.
Exactly. An element is an atom. Yes. Okay. Determined by the number of protons. Okay. Neutrons and electrons. Okay, so each element has one type of atom for now. Okay, let's say for now, because chemistry, science is developing. Okay, I don't want to take you to something else, yeah, but for now, let's say that each element has one type of atom. So it has one specific number of proton, one specific number of an element. Let's say we look at hydrogen. Okay, hydrogen. The first, we say there's a K cell. When we draw the atom here, we did like this in it. We say this is nucleus in it. And this is the K cell in it. Or they call it first cell in it. First cell. And this is the L cell. Or they call second cell. Okay? Now for hydrogen, the symbol is like, we are going to do the symbol today, okay? How the symbol of an element is. Hydrogen is written as H, capital H.
Yes.
Capital H. Don't ever write like this as hydrogen. No, it's capital H. There's one proton and one electron in atomos cell. For this one, it is the atomos cell because it has only one cell, so it is atomos cell. Okay, but it has one proton which is positively charged. With pen. With pen. It has one proton which is positively charged and one electron which is negatively charged. Okay, so basically they balance each other in this. -1 + 1 is equal to 0. Yes. Okay, 0. Okay. Now, the proton is 1, so this first element is called hydrogen. Now, if you have, let's say, helium, which has 2 protons in it, okay, but 2 electrons. Let's say proton, we put like a cycle. So this cannot be called hydrogen, because hydrogen has only one proton, and helium is written like this, He in it. He. Okay, the first letter is always, if an element has 2 letters, the first one will be capital and the second one will be small, lowercase. Yes, you call lowercase. Yes. Okay, so since it has 2 protons, they call it helium. Now we'll do our next topic will be periodic table. How the elements, 100 and something elements are arranged in groups based on how many electrons they have in the outermost cell.
Oh yeah. Group
Yes, I think we did it last year.
Yeah,
Yes.
and
Group A, Group B, or Group 1, Group 2. Okay, we'll come to that later. Now, helium has 2 protons and 2 electrons. So, minus, okay, plus in it. So, minus 2 plus 2 is equal to 0. Do you understand? Yeah. That's why when they give you the number of protons inside the nucleus, you must automatically know that the same number of electrons will be in the cells, in it. Yeah. Okay? But let's look at another one, sodium, which is very, very common. Okay? So, sodium has 11. When you write at the bottom, I told you when you read the number down is what?
This.
The atomic number in it. Yeah. So let's say this is 20. 23, yes. Yes, you know it. Okay? That means how many protons are there?
11.
Do you know? 11. Why?
Because the amount of protein is same amount of time.
Exactly. But how many electrons we have? Remember, we said, yesterday we said the innermost cell, which is the K cell, can take only 2 electrons. So you cannot put 8 here. And after that, all the other cells can contain 8 electrons, not more. Okay? So, we look at this. Let me bring this sodium here. So, you can see capital A and a small, capital N and a small a, 23, 11 in it. Okay. So, we said the first one will take 2 electrons. The next one can take 8 electrons in it. Yes. So they're always written in pairs. In pairs.
Is it group 1?
Yes, it's in group 1. Now how many is left now? 1. That will be in the outermost cell. They call the outermost cell, we can call it KLM cell, yes? Yes. So there will be 1 electron out here. You see? Okay. So therefore, sodium, in the nucleus, there will be 11 protons in it. And how many neutrons?
It's 23 minus 11.
Yes, because we said that number of neutrons is the mass number minus the atomic number in it. So 23 minus 11 is equal to 12. That's right. You see, on GCSE, they break something like this. Now, since all the electrons are negative, this 11 will be positive, the rest will be negative. Electrons will be negative in it. Protons positive, electrons negative. So they call this sodium because it has 11 protons. If it has one more proton, it will be a different element. Do you see? So you see the distinction between atom and element. Okay, each element has only one type of atom based on the proton in it. Yeah. Yes. If this become 12, we will not call this sodium now. We will call it magnesium. So therefore, magnesium, which has 12 protons, okay, 1, 2, 3 in it. It's called magnesium in it. 24, 12. Okay? So the mass number is 24. The atomic number is 12. So there will be 12 protons inside the nucleus. So that's why they call this one magnesium. If there's another one with 13, it will call another element in it. Okay? So the element, the name of the element basically will depend on the atomic number. You understand? Yeah. So if somebody, you do your PhD, you discover an element which has 200 protons, you call it maybe let's say you know. So if you do your PhD, in Leicester University, you discover an element, a rare element, which no one had discovered before. All these elements have discovered by somebody in it. And the atomic number, when you do some research using a mass spectrometer, there's an instrument called mass spectrometer. When you do A level, you will learn about mass spectrometer. You learn that the atomic number is 250. That will be a heavy metal in it. Then you will say that, look, I discovered an atom which has an atomic number of 200. Then I call it Jamekundayum, or I call it Leicesterium. Do you understand? Because most of them ends with yum in it. Calcium, magnesium, lithium.
Beryllium.
Okay? Or Dawakundayum. Okay, you see. So now, if this has 12, if it has 12 protons, automatically we have 12. How many electrons?
12.
How many would you have in the first cell?
2.
2. Because?
Is the K cell.
Because the K cell can take only 2. How many will you have in the L cell? 8.
Is it group 2?
In group 2, yes. We'll come to group now. Later. Now, how many electrons?
There's only
10. That means we have another
2.
cell in it. Yes. That will be the outermost cell. So basically, when we go to groups, we know that the element in the next one will have another shell. You understand? Yeah. The element will have another shell. Good.
Dad, but wouldn't it be in pairs?
Hmm?
Would it be next to each other?
No, they will be in pairs. When electrons are not up to the maximum number of electrons in the shell, you don't put them in pairs, put them by their own. So if they are, let's say this is reacting with oxygen, okay? That's right, one oxygen will be here in it. Yeah, in a covalent bond in it. Yeah. So something like that. That's why they normally leave it out like that. We'll come to covalent bonding and all those stuff, yeah? Since I'm teaching from start, I don't want to go into all those things, to jump the gun. That's what they call jump the gun. Now we can see, therefore, an element, its position is determined by the proton. Okay? That's why elements are arranged in groups in it. Yes, they are arranged in groups. Now, as you know, the structure of an atom can be drawn like this, based on how they call it atomic structure. Okay? So sodium will have 2. This is nucleus, isn't it? Yeah. Sodium have 2 here, 8 here, 8 here, and in the outermost cell you have 1 in it, because it's 11. Sodium, 11 here, 23 here. Now this is the atomic structure. But you can also do it in a different structure. Okay? That will be in numbers. You don't want to jump the gun so that so the electronic structure, this is atomic structure. Atomic structure will be written in numbers, because you start with the K, L, M, meaning first cell, second cell, third cell. Here M will be the outermost cell. Now, how much electron can the K cell take? 2. What about L? 8. And for sodium, how much is left now? 1. So the electronic structure will be 2, 8, 1. Meaning there are how many electrons? 2 plus 8, 10 plus 1, 11. And that is the atomic number. This is called the electron structure, okay? Or electronic structure. Okay? And this is the atomic structure. Seeing how the electrons are arranged in it. Okay? Now this is very, very important, because we are going to learn that when sodium reacts with something else, it will lose one of these electrons and it becomes something else.
Release it to have an outer shell.
Yes.
A stable outer shell.
Yes. When you release this electron, donate it, we do type of bonding, and then this will become sodium ion. So we do ion, positive and negative ions. Okay? Positive and negative ions. Okay. Now, let's look at the periodic table. I'll go over everything again and make sure that we don't leave anything out. Okay, according to the syllabus. Periodic table. This is very, very important in chemistry. You must know this. That the element, they are more than 100, and there are now about 120 something elements.
26, I think.
Yes, and these elements are around in a period or in a tabular form, yes? So depending on the number of protons they have, okay, and in the outermost cell, the number of electrons they have, I told you atoms differ in the number of protons they have, okay? But periodic table arrange elements based on the number of electrons in the outermost cell. So, if an element has one electron in the outermost cell, it will be as group 1. If you have one electron in the outermost, 2 electrons in the outermost cell, it will be group 2. If you have 3 in the outermost cell, it will be group 3. You understand? Yeah. So group 1, all the elements in the outermost cell will have one electron in the outermost cell. Group 1, all the atoms with one electron in the outermost cell will have one electron and they'll be in group 1. Okay? So group 2, they'll have 1 electron, 2 electrons in the outermost cell. Group 3, they'll have 3 electrons in the outermost cell. Okay? Okay. That's called the periodic table. That is arranging the elements based on the number of electrons in their outermost cell. Now, you have gone on to group 4, 5, 6, 7. In it? Yes? So, now, an 8 will be, they call it group, they don't call it group 8, they call it group 0. Group 0,
Noble gases.
noble gases, okay? Yes, noble gases. Because they have 8 in the outermost cell. We will know all that. What are the characteristics of noble gases, yes? Now, those here, we can safely say that they are called metals. Okay? Those in group 1, 2, 3, they are called 4, they are called metals because they can donate electrons. They have less than 6 in their outermost cell. Yeah. Okay? They are called metals. But the ones with, let's say, even 5 it look metal, but one is 6 and 7, like chlorine, okay? They are in group 7 because they have about 7 electrons in their outermost cell. Yeah. Okay? Instead of giving now, they will receive electrons. So they are called, these are called group 7. Most of them are gases. Yes. Or group 7 metals. Okay? Even before we would look at the periodic table, in 20 minutes, we will look at the symbols of the elements. Okay? Hydrogen is written as that. Okay? The next one, helium, is written as that. The next one, 3, is written as that. The next one, beryllium, is that. Okay? Then you have carbon, only C. So important ones, I'm telling you, sodium, Ca. Magnesium, Mg. Calcium, Ca. Big capital in it. Okay? Potassium, K. Okay? The most important elements are 20 that you deal with in GCSE. There are 20. I'll list all of them for you. Okay? Boron, B. Now I'm going to put them in the periodic table based on the number of electrons in the outermost cell. Okay? But these are the symbols of the elements. Okay? So if you write them, hydrogen will be written like that, helium will be written like that, lithium will be written like that, beryllium will be written like that, carbon this, sodium that, magnesium, calcium, calcium. Okay? You should know how they are written. I see that. Okay? So Next time we're going to deal with periodic table now, how they are arranged and how the arrangement affect their characteristics. Because definitely if you arrange element in a group, then the group must have the same, the element in that group must have the same characteristics, same type of reaction, nearly same similar physical features, nearly same chemical features. We're going to do all that here. We will end this lesson 3 here, and later we'll look at the periodic table in detail. Okay?